Okay, a little bit more about the brownie problem. One of the other questions was how much is left of the brownies at any one stage right here. So you can look at these terms in this way. This is the amount that they eat. They always eat 2/3 of what was left from the last time they ate. So in this case, 1/3 times 1/3. So if you do that here, you would say, well, this is the amount they ate, and this is the amount that was left. And then you go to this first term here and you say, well, that's the amount that they ate right here, what was left. Well, just to be consistent with all the terms, you would say what was left was 1, the whole pan. So that's a special property of 1. Multiplying by 1 never changes the value of anything, so you can always put it in as one of the factors of a term if you want. And in this case, we want to do that so we're consistent and we always have how much they ate times what was left. So then the next thing to do is to look at this and see if we see a pattern and if we can fill in the next step. Well, the next step here would be this. Here's how much is left the last time we left off with this problem. If the third friend still doesn't show up, they divide that up into thirds. They eat, each of them eats 1/3 of that, and then what's left. Well, if I just look at my pattern right here, they're going to continue to eat 2/3. And what's left is going to be 1/3 of 1/3 of 1/3. So in this case, I'm going to have 1/3 times 1/3 times 1/3. And then it goes on forever from there. So you look at this, that's 1/27. If you wanted to, you could divide this up all the way around like this, count the number of little rectangles you have, and what you would see is that you would count 27 of those, and that's the 1/3 times 1/3 times 1/3. So if you look at this in any one term, you can see how much was left. Here's how much they eat. In this term, here's how much was left that they had to eat, what was left for them to eat. So that was what was left. So in any one term, you can see how much is left. If this goes on forever, though, how much is left? And the answer is there's always some left, because I can continue to do this forever. The amount that's left is always smaller and smaller and smaller, but it never gets to 0. It goes on forever like this, so there's always some left.